A car is driven by an engine with a given power. However, the amount of torque originating from engine power is not always enough to move the vehicle, so the torque must be increased. The lower the revolution of the gears, the greater the torque. In transmission systems, the engine torque is modified by reducing or increasing the number of revolutions per minute, or RPM. The RPM can be changed by selecting gears. The smaller the gear that drives a bigger one, the smaller the rotational speed of the bigger gear, and thus the greater the torque. To enable the engine to move the gears, a connection has to be established between them, which can be disengaged if needed. This is the job of the clutch. The optimal RPM is adjusted by setting the appropriate ratio of the gears. With the clutch pedal released, the engine drives the input shaft and thus the wheels. With the clutch pedal pressed down, the crankshaft revolves without driving the transmission and the wheels. This enables us to shift gears. To avoid grinding and weary shifting, gears need to be synchronized, which means meshing gears rotating at the same speed. A synchronizer ring makes that possible. With a clinging surface and sloping edges, the ring equalizes the rotational speed of a pair of gears and engages them, making the gear change noiseless and smooth. In synchronized transmission systems, all the gears are constantly in mesh. While the gears on the lay shaft are in a fixed position, the gears on the spline shaft rotate on their own bearings. Shifting between gears occurs by fixing the current gear to the spline shaft, so the drive goes through the pair of gears. To get the vehicle moving, we shift into first gear. The linkage, with the help of the sleeve attached to it, fixes the first gear on the spline shaft. The drive through the input shaft goes from the smallest gear on the lay shaft to the largest gear on the spline shaft. Since more torque is necessary to start out, first gear has the biggest gear ratio, meaning the smallest gear is in mesh with the biggest one. When the vehicle has reached a certain speed, less torque is required to keep it moving. The ratio of the succeeding gears becomes smaller and smaller. The driving gears and the driven gears are nearing the same size. In second gear, the sleeve fixes the second gear to the spline shaft, conducting the driving force through it. In third gear, the sleeve fixes the third gear to the shaft. The drive goes through the third gear on the lay shaft and the third gear on the spline shaft. The speed is increased while the torque is being lowered. In fourth gear, the speed increases further by lowering torque. In this case, drive goes directly through the input and output shafts. No gears are involved in the transmission. The RPM of the engine's crankshaft equals that of the output shaft, hence the name direct drive. In reverse gear, an additional gear is applied between the last gears on the lay shaft and the spline shaft. It changes the rotational direction of the output shaft, moving the vehicle backwards. In lower gear, the car is slower but pulls harder. In higher gear, the vehicle is faster and uses less fuel but has weaker acceleration.